So here we are another day, and this time I will try to teach you the commands that we need to send to the Arduino so that we make the OLED display show exactly what we want. Okay, let's go and see. Here I have a new file on the Arduino IDE. Let me increase the fonts a little bit. Wait. So now you can see exactly what I'm going to write. Okay. First, at the top, we have to write down some things, but you don't really have to know exactly what all these things mean. Let me do it first and I will show you. Okay, so here we include some libraries. Okay, these are the 4 libraries here that we need to have included in our program. What is a library? A library takes easy understandable commands and translates them to complex commands that certain hardware need to function. So we just use common words, and the library uses this as input, and the output is the commands that the hardware will require to function. Okay, this library here, it's the library that is specific for this OLED display, and this library here is the library the Arduino IDE uses to make some graphics, so rectangles, lines, points and stuff like that. Okay, this is the address of our OLED display. Normally this is the default address for all these displays, so I will leave it like that. Here we define the width and the height of our display. Here we have to issue this command, I don't know exactly why, and here, okay, this is a command that initializes our display and tells to this library here some specifications about our display. All these lines here, you just have to copy and paste them like that. You don't need to know exactly what they mean. It's none of our business. Just paste them there and it will work. So, next. We go to this, I will wipe away this line. We go to this void setup. If we, as we already said, this setup routine is just executed once. So what do we have to put here? Okay, this starts the display. Okay, this is the address that we defined here. Okay, you don't have to understand what does this mean. You just paste it there. Then we will issue a command that waits 2 seconds. Okay, this is a 2-second waiting, and then we will issue these commands that clears the display. Okay, and now we will go to the loop function, and this is where all the nice stuff works. Okay, this is our first command that we have to learn. Let me explain you what this means. This means that draw a pixel on the display on the point with coordinates 10.5, and this here tells the library that this pixel must be white color. Okay, I will explain you what does this mean. After we issue a command for the display to show, we have to issue this command, which tells the library that go and display what we defined here. So why do we have to issue this command, and why won't the display just display right away this command here? So because sometimes we want to display many things on the screen, so we have to define all of them and then issue this command here for the screen to display all of them at once. Let me now send this thing to the Arduino so that you see what happened. Ooh, what do we see here? So here, as you can see, we have a pixel. Okay. And that pixel is exactly on the coordinates 10.5. Now I will display more pixels. Let's see. 10.5, 10.10, and 10.20. I will send this to the Arduino and let's see what we got now. Now we have 3 dots on these 3 coordinates that we issued. Let's expand this further to the right. So instead of 10.5, we will put another pixel on the 20.5, and now we'll have another pixel to the right of the other ones. Let's see. Ah, there it is. So we learned one command, which is the command draw pixel. Okay, let's learn some more commands. These 2 characters here make all this line be just text without any other meaning. Okay, but I will leave it there so that we can have a reference of what commands we have learned. The next command we are going to learn is the command draw line. Okay, a line is defined by 2 points, so we have here, we have to write down 2 points where the line starts and where the line ends. Okay, so let's say the line starts from 10.10 and ends to 20 by 10. Okay, we will delete these 2 and let's see now what the display will show. Now we have a small line. Let's expand the line further so that we write here 100. Can you see now what we see? We see a line. What I don't know is if the other numbers is how much away the second point is, or the exact coordinates of it. So I can see that by doing this. The next line will start from 20.20, and let's see if these two lines will stop at the same point. You see, we have two lines and they stop at the same point. So the first two numbers are the coordinates of the first point. The second two numbers are the coordinates of the second point. Right? I think this is easy understandable. We can, for example, make a line, a diagonal line. It doesn't have to be straight. Let's see. You see? So if we know the overall coordinates of the display, which is 128 by 64, whenever we issue commands that have the coordinates inside this range, we can draw certain graphics on the display. Okay, so let me just comment out this line, and we will do now, we will learn another command. What is the other command? The other command is the fill. No, I will first show you this draw rectangle. Okay, so our library can draw a rectangle. How do we do that? We issue the first point, then we issue the length of the rectangle, which is 100, and the width of the rectangle, which is 50. Let's see now what we will get on the screen. You see, now we have a rectangle. If we put 20 here and try this again, we will see that our rectangle will have the same length but a smaller width. Let's see. You see? So now we know that we can issue easy understandable commands, and our display will show what we commanded to show. That's what this library here does, and this library here. That library here has the commands to draw stuff. That library here translate the commands from this library to make the screen show what we want. So I will comment out this, and I will teach you now the last command that we need to know. The last command is the fill rect, which is a fill rectangle. Let us see now what we will get. What did we get here? We have a rectangle, but it is filled with white lines inside. So it's not that the perimeter of the rectangle is all of it. Okay. These are the commands, these four commands: pixel, line, rectangle, and fill rectangle. These are the only commands we need to know, to be able to draw VU meters, to make our display act as a VU meter. Okay, let's play a little bit with some of these commands. I will leave them here as comments, as just text. Okay. If we don't issue this command at the end, whatever command we write here will not display on the screen. Okay. So let's draw a line. Okay. But now we will draw another same line but black. Or no, I will do a filled rectangle. Okay. And then I will display my second line. But what if we do this? Our display will show the white and the black rectangle very quickly. So I will put a delay so that we are able to see. I think half a second is okay. Okay, and now let's see the result on our screen. Listen what we did. We draw a rectangle, okay? We wait half a second, then we draw the same rectangle but black. So what actually happens is that our first rectangle is erased. That's what it just turns off the small LEDs on the screen, the black command, the black color. So that happens every half a second. As we know, this loop function is executed over and over, again and again. So we go here, we start from the beginning, we come here, we draw this rectangle, we make the screen draw it, we wait half a second, then we draw the same rectangle but black, we make the display show it, we wait half a second, and then again from the beginning. And this is the result. Okay, so now you can understand how we control this display by issuing commands. Okay, now I will try and do something a little more complicated just to show you what this can do. For I equals 0, I plus I less than 129. Right. I'm not sure if I have to put a comma or a semicolon here. We will see on the way. Now, I will draw a picture, a pixel. Let's draw pixel 10 and I white. Then I will make the display show it. Then I will wait for 1/10 of a second, and then I will wait for this function to end. Let's see what we get. Error. So it needs a semicolon and not a comma. Okay, I hope it works now. Let's see now what our display will show. I did a mistake. I made it go to the bottom, although I wanted it to make go to the right. It's no big deal if we issue pixels that are out of the screen. They are just not shown. But now I will do it correctly. I will put here I, and I will put here, let's say, 2 end. Now the line, the line that we are drawing will start going to the right. So, what do we see here? As we can see, we have some movement on the display. Just before we didn't have any movement. It was just stable things. Now it moves. What did we do here? Let me show you. We did a loop, and the I will start from 0 and will keep on up to 128 because it's less than 129. So for the first loop, the pixel will be displayed on point 0.20. Okay, it will be displayed, and we will wait 1/10 of the second. Then the loop will come back. Now the I will be 1. We will draw a pixel on 1.20, wait 1/10 of a second. Again at the beginning of the loop, the I will become 2, and we will draw a pixel on line 20, but on column I. So on column 1, 2, 3, 4, 5, 6, up to 128. And this is exactly what happened. Okay, as you can see here, it started from 0 and it went up to 128. Let's go a little bit further and issue another loop, but this time black. And this delay, I will make it less. Let's see now what we will get. What did I do? I need another to close another function. That's it. Let's see now what we will get on the screen. Now it's going faster because I decreased the delay, but now the line is erased. Then it is shown again. You see here what I did? I started and I draw every pixel up to 128. Here I drawed I made another loop here that draws a pixel up to 128, but black, so it erases the previous. Let's make it a little bit faster to make it more fancy. You see? Now we have a permanent movement on our display. Isn't this nice? It's just a movement that goes on and on. So I will delete this second loop, and I will show you something else that we can do. This time we will draw a line. Okay. And we will start from let's see, from 0.20, and the line will go up to I plus 20, and again on line 20. Okay. I will do this on line 30 so that you don't confuse it with this I plus 20. What this will be, it will be the length of a line. Okay. And I will draw another line. No, I will draw a pixel here. And this pixel will be the I minus 1 pixel on line 20, but this time it will be black. And now I will do this delay 20. Let's see what we will get on the screen. That's not what I wanted to. 20. I should do this 30 because we were on line 30. Now it will, I think it will show what I want. Let's see. You see? And it goes on and on. I don't know if you understood here what I programmed, how I programmed this to function, but I will show you. Here we draw a line on line 30 with a length of the line 20, because the next point of the line will be drawn up to I plus 20. Okay? But we go here and we erase 1 pixel before. You see, if we don't do this, the line will not be erased from its back and it will continue up to the end. Let me show you what will happen if I will comment out this erasing command. You see? That's it. And the line is drawn above the before, so you don't see it being drawn. But by having this command also, every 1 pixel before the line is erased. So now the line is as if it's going forward. You see now how it works. So, the last thing I want to show you that you learn is with this fill rectangle command. And let's see what we will do here. We will start from column 0 and line 10. Okay. and the thickness of the rectangle is 20, and this 100 is the length of the rectangle. Let's see here, let's define a variable that it signal equals 1. Okay, and make this rectangle go up to our signal. I erased, let's see, I deleted this display function, and let's make this signal 50. Okay, and let's see what we will get. Okay, we got a signal up to 50. Now I will give a new value to this signal variable and make it 120. Let's see now what our OLED display shows. It shows a rectangle that goes further away. What have we learned from that? That the bigger the signal, the further away our rectangle is drawn. So what do we just have to do? We just have to input some audio to the Arduino and tell the Arduino that compared to the strength of the signal, okay, that you receive from the audio, make this variable with a similarly high number. So low audio signal, low number on the signal variable, high audio signal, high value on the signal variable, and then draw a rectangle here, which will be the length of the rectangle will be proportional to the signal we receive in the Arduino. Okay, so we have learned how to manipulate our display and make it show what we want. Okay, now we will learn how to make the Arduino read audio, determine the strength of the audio, and give a command to the OLED screen to display a rectangle that shows how strong this audio signal is, which is actually it's a VU meter. Okay, closing now this video, and next time I will show you exactly that.